All right, for the second one, there's two things that happen. There's a negative and then there's a -5. This would happen to the x first, so I should say this first. It shifts 5 units to the right, and then it flips over the x-axis. It's easier to write flip than reflection for me. Number 3, this shifts 4 units left. That's got to go first, and then it shifts 7 units down. For the third one, the first thing that happens is this negative, so it flips over the x-axis, and then it translates down 3 units. And then for the number 5 here, these do not cancel, that's for sure. This first thing will flip over the y-axis, and then the second negative will flip over the x-axis, and then the third thing is it will go up 3. For all transformations that are shifts, which means I'm adding or subtracting something, or flips or reflections, which means I'm multiplying by a negative, the resulting graphs are congruent to the original parent graph. Okay? Here's our last thing for the chapter. Part 4 from section 2.5 is about stretches and what the book likes to call compressions. Another way to say that is contraction or shrink. These actually change the shape, they distort, they change the actual shape of the parent graph. If you multiply a constant, you multiply some number times a variable in the function's equation, the result will be a stretch, or I guess a compression, according to the following rules. Number 1, if g of x is equal to a times f of x, so I multiply a number times the entire function, it will be a vertical stretch because all of the y values from the original f of x function, every y value that I get, I'm just going to multiply by a, so it'll be a times as high. Now, if I multiply by 1 over a times f of x, that will be a vertical shrink. Goes like this, or the fancy pants word from the author for this is a compression, because all of the y values, after I put something in for x and do the normal f of x function, what will happen to all the y values is every single one of them will be 1 over a times as high. So that's what happens there. Go to the next page.